In this third video of introduction to Arduino board, so let us continue with this light sensor instead of a push button to turn on an LED. So in the you can see this is we are actually reading the LDR output through this A0, and that value will be assigned to this val, which will actually change the delay of the LED, which is going high and low. So if this voltage is more, then it will be on for longer time and off for longer time. So both on and off time depends on the value that is being read over here. Suppose the value is low here, then it will be blinking fast. If the value is high over here in the analog, so the blinking rate will be very slow. Now we shall see one more program where we are having set the brightness of the LED to a brightness specified by the value of an analog input. So now here in the previous example, we have seen the LDR output is used to change the delay of the on and the off time. Now here we can actually see how does we can change the intensity of the LED, which purely depends on the analog input which is obtained from the LDR. Now you can see the LED is now is connected to pin number 9, and initial val is been initialized to 0. So now only one pin that is used as output pin is LED. The other pin is input pin, which is an analog input, so that need not be specified over here. So only pin mode is used to specify the digital output. Now you can see here in the infinite loop, the val will get the value of analog read. So analog read, now LDR output is connected to analog 0 here. Whatever the analog value that comes from that junction of a resistor and the LDR, that will be assigned to val, and we are writing that val value, that is VAL value, onto the LED using this. So now this is analog read 0, means the it actually read the value from the sensor to the val, which is an integer which is declared here, and that value analog write will be written because you are writing an analog value onto the LED. Now it is, now why this is LED is, you can see now it is given to pin number 9. You can remember that pin number 9 is one of the PWM output. Now you can see this LED is not connected to 13. In 13 you can give only high and low, whereas in the analog output pins like 3, 5, 9, 10 and 11, so we can actually give a analog output also. This 9 is one of the analog output pin. Now you can see now analog write, LED gets the value. Now you can see one specific thing, so it is val by 4. Whatever value that is read from this will be divided by 4. So why this divide by 4 is because when you are actually reading any analog data, it will be varying from 0 to 1023, whereas an analog write you can write maximum of 254. So 0 to 255 you can write it. So but whereas you can read from 0 to 1023. So 1023, 0 to 1023 happens to be 1024 values, whereas you can only write 254 values on 256 values only you can write. So that's why we are supposed to whenever you made an analog read, the maximum value that can be written on the LED is 256. So that's why we are writing it as val divided by 4. Suppose if you simply write val, the value will exceed 255, so then we'll not get a proper result over here. So that's why it is val by 4, and of course it will be there up to a time of 10 millisecond. Now it will be there in the infinite loop. So the brightness purely depends on what is the value that is read from the analog read. Now using Arduino board, we can also do a serial communication. Now this is one such program where we are sent to the computer the value read from a analog input 0. Make sure that you click on the serial monitor after you upload this program. So we can actually open that serial monitor and we can actually see the value that is